Meta-arguments in real projects. Meta-arguments are not provider attributes. They are Terraform language controls that modify how Terraform Core constructs the dependency graph before the provider executes any API call. Meta-arguments operate at the graph level, not the provider level. They instruct the Terraform Core engine how to handle the object before the AWS provider ever sees a configuration attribute. The outcome is global behavioral control. The same mechanism works across all resources because the Terraform engine interprets these instructions before provider logic begins. Count creates multiple instances by assigning a numeric index to each object. The mechanism is positional identity. Terraform stores instance identity as index 0, index 1, index 2. The outcome is fragile ordering. Changing the input order changes instance identity, which can trigger unintended destruction and recreation during refactors. The count value must be known before Terraform performs remote operations. This requirement prevents count from depending on attributes generated after apply. For each generates instances from a map or set. The mechanism is key-based identity instead of numeric indexing. The outcome is stable infrastructure addresses because Terraform tracks instances using meaningful keys such as dev or prod. Terraform does not automatically convert lists into sets for each. The value must already be a map or set before planning begins. Terraform normally infers dependency order by analyzing attribute references. Hidden dependencies appear when one resource depends on another resource's existence, not its data. The depends on meta argument injects a manual edge into the dependency graph. The outcome is deterministic ordering when Terraform cannot infer the relationship from expressions. Because it modifies graph behavior, depends on should be used sparingly. Terraform's default update strategy is delete, then create. Many cloud resources cannot tolerate that replacement order without service disruption. The lifecycle block acts as policy as code shim. It allows you to override Terraform's default behavior that often causes outages during infrastructure updates. The mechanism introduces execution guardrails such as prevent destroy, create before destroy, ignore changes, and validation rules. The outcome is controlled change management embedded directly in the configuration. On a submarine, machinery often includes physical interlocks that prevent a destructive command from executing without a second verification. Prevent destroy acts like that interlock. It doesn't make the system indestructible. It blocks the most common class of operator error before the command reaches the machinery. Terraform supports multiple provider configurations within the same project. Each configuration may target a different region or account. The provider meta argument selects which configuration Terraform uses for a resource. The outcome is multi-region or multi-account deployments without duplicating resource definitions. Meta-arguments are the architectural skeleton of Terraform code. Adding them after a resource already works is like trying to change a building's foundation after the walls are up. The mechanism is Terraform's dependency graph construction. Terraform determines identity, ordering, safety constraints, and execution routing before any provider API request occurs. The outcome is that early design choices determine how safely a project can evolve. Choosing count when stable keys are required or adding lifecycle rules too late forces disruptive refactors once infrastructure already exists.